Can you recall a family dinner where the topic de rigueur was climate change related to pollution, global warming, or water contamination? What if there was another wicked problem, often not known and overlooked? In 2015, the Food and Agriculture Organization of the United Nations reported soil contamination is one of the main threats affecting the world's land surfaces. The source of this type of pollution can be linked to chemical products used in agriculture, manufacturing, and even in military operations. These substances, containing one of the primary sources of soil contamination, heavy metals such as chromium, lead, nickel, copper, cadmium, and arsenic, end up being released into the environment. But that's not all. Did you know that your garbage can contribute to this problem? After garbage is disposed, it usually reaches local landfills, producing leachate, liquids coming from waste decomposition containing heavy metal that seep into the soil and water. Despite the pandemic's limitations, we were determined to find a biosolution by co-working with a farming community. That is why we arrived at Mochuelo Alto, a rural community in the outskirts of Bogotá, Colombia's capital, located next to the city's landfill. Today, a population of 5,000 people depends on agriculture as their livelihood. They are directly affected by leachate metals, causing contamination in water sources and altering the soil's biodiversity. These metals also reduce organic matter, drive harmful effects in plants, inhibit growth, and nutrition assimilation in crops. The economic costs for the community are directly related to this waste problem by having low productivity and crop quality reduction. But did you know that even the most committed consumer faces risk due to the produce exposure and intake of contaminated vegetables and animal-sourced food? The impact on the consumer could be associated to health issues, as heavy metals are related to cancer and adverse effects on their nervous, respiratory, reproductive, and cardiovascular systems. LixiLab was born to empower small farmers who produce 70% of food in Colombia and who represent 90% of the world's agricultural community. We recognize the importance to bring the farm-to-table movement to this community and foster organic, seasonal, and local produce, supporting Colombia's farming communities. LixiLab is a grassroots, feasible bioinnovative solution, joining science, design, and systems thinking with empathetic design methodologies. LixiLab is a bioremediation technology using the bacteria Licinibacillus sphaericus CBM5 for extracting heavy metals in farmed soils. But how does this all happen? We co-designed with a LixiLab influencer. Licinibacillus sphaericus CBM5 is a bacillus-type non-pathogen bacterium. It is isolated from uranium mining waste piles and petroleum exploration sites, and studied for bioremediation purposes since its superpower lies in the fact that it is metal resistant. This sucker can accumulate heavy metals like lead, chromium, cadmium, arsenic, and even degrade hydrocarbons. What? Really? No way! An authentic bioinfluencer. But wait, that's not all. The bacterium works even if it's dead. Yes, you heard right, as dead bacteria. According to research, Licinibacillus sphaericus CBM5 absorbs metal after it has completed its life cycle, just like it did when it was alive and kicking, because of its self-assembling protein, known as the S-layer, that can self-assemble in two-dimensional structures trapping metals in its microscopic holes. Additionally, it works with functional groups, which gives bacteria its affinity to metal ions, facilitating metal adsorption. This layer is found negatively charged on the cell membrane. Therefore, bacteria can absorb positively charged metals. Also, it has amazing advantages because of its lack of metabolic susceptibility by environment fluctuation given by undesired horizontal gene transfer from other microorganisms. The farmer community at Mochuelo was skeptical about introducing living bacteria into the soil because of all the bad rap it has, especially right now. Our technology applies the bacteria in a dehydrated hydrogel matrix made of a chitosan and alginate blend that works in water and soil. We chose those biopolymers because these are non-toxic, biocompatible, biodegradable, and are obtained in large quantities all over the world at a low cost. LixiSoil, our first biotech application, contains a biofilter which prevents and diminishes the number of heavy metals in agricultural soils. It's designed to control contaminants on surface-rooted plants like vegetables and tubers, measuring up to 60 centimeters or 2 feet. After introducing it to the soil, a porous version of the hydrogel is inserted, and then water is added so that the bacteria can have better contact with the earth. This hands-on practical system works along with the farmers' knowledgeable practices and tools. The root-inspired capsule design is buried in the soil. Its packaging contains chitosan and alginate spheres soaked with dead bacteria. The container is inserted into the ground according to the farmer's need. A fence with several filters can be placed individually at a variety of locations on the land. The design is easy to use. Just unwrap the package and insert the hydrogel spheres and water into the capsule. Leave LixiSoil until the conductivity sensor indicates and refill with a new package or remove the capsule for seeding. After changing the matrix, farmers will return the packaging with the bacteria-filled metals for collection at indicated locations in public and communal spaces. LixiAqua is our second biotech application, designed for implementation in water sources used for irrigation, storage tanks, ponds, and other daily uses. It contains the hydrogel filter coated with dead bacteria. LixiAqua should be placed in the medium up to 1 day to do its filtering process. At the end of the sphere's life cycle, metals are extracted from the bacteria in a lab. The service is included with the product, in which trained professionals methodically remove the metals. The system is low cost and uses a certified polymer biocomposite that is easily recyclable and has neutral carbon footprint. LixiLab's mission is to make toxic-free crops possible, increasing good health and well-being of farming communities and consumers, preventing heavy metals leaching from landfills, reducing the risk of people suffering diseases. LixiLab's Sustainable Development Goals shared commitments towards zero hunger by preventing waste and crop losses, and obtaining more fertile productive lands also guarantees the ecosystem's biodiversity and reduces land degradation. When comparing LixiLab to other soil remediation technologies as soil washing, thermal, and electrical treatment, it has shown that its biotechnology reduces human and environmental risks. It is low cost, and it does not require continuous maintenance, nor does it require fossil fuel energy or other finite resource other than the water or humidity found in the environment. LixiLab can also be useful in areas where mining has been conducted or militarized zones that have released heavy metals in the soil. Our professional team will keep working diligently to continue creating new biotech applications. Our next step is to reinforce the material matrix, creating a durable, tough product that meets quality standards and benefits underrepresented communities that otherwise would not have access to a bioremediation procedure. LixiLab, strengthening farming communities from the soil up.